Okay, let's go over the third exam here. So beginning we have an equation here, and even though I tell you that this is a circle, technically you wouldn't need to know that because when you put it in its final form, you would see, for example, that both of these squares are positive. So that would tell you that it is not a hyperbola, but it is indeed a circle, and we know that because we're taking half of this -2 to get the -1, half of this 8y to get the 4, it tells us our center is at +1, -4, and then we take the square of this, the square root of this to get the radius. Okay, couple things to point out here. One, we have a y squared and just a plain x, which tells us that the parabola will open left or right. Because this is a positive term out here, we know that it does open right. So one thing I would recommend that you do is try plugging in some points. For example, plug in a value for y that's pretty easy to get, and just check where some of your other points are beyond the vertex. If you're not sure whether it's opening right or left or up or down, just plot a couple points, no matter what you're doing here, parabola, circle, hyperbola, anything, to give you a clear picture. So the advantage of an equation is that you can always plug in points and they should lay on the graph of the equation. Okay, which is incidentally what I think I did here when I couldn't remember quite if this was a horizontal or a vertical. So yes, even teachers have problems with this sometimes. And I figured it out quickly though when I started plotting the points. So in this case we get x squared over 32 plus y squared over 81. Certainly both of these should be positive. Now in a hyperbola, we know that one of the two terms is going to be negative, and because when I graph this out, I see that they're opening up horizontally like this, then I know that it's going to be the x's that are positive and the y's that are negative. Now in terms of, let's say you couldn't quite remember what A is, what B is, what C is, again, real quick way, let's plug in a point that's on the curve. Now notice we cannot plug the center in. Why? The center of the hyperbola is not actually on the hyperbola, and so it won't fit this equation. But the same as the focus. But the vertex is this point here on the hyperbola, these two vertices. And so let's plug that in, 2, 0, into our final equation. If we plug 2 in for x, we get 4 over 4. If we plug 0 in for y, we get 0 here, so we get 4 over 4 equals 1. If I had switched these up and put the 32 over here, the 4 over here, or if I had maybe put a 36, several people had a 36 denominator, I would get an equation here that's not true. So that would cue me into the fact that, oh, one of my denominators is switched around, or maybe I put in a C where I should put a B. So just take that last step to check once you get your equation for any of these conic sections, plug in a point that's on the actual graph of the equation and make sure that it does fit. Okay, using any method to solve, I'm using the matrices. Several of you used the substitution and elimination methods, which are perfectly fine. They get a little cumbersome with this many variables, but perfectly fine to do that also. And one thing I want to point out, when I'm saying add 1 and 3 to 2, I'm not saying add the number 1 here or add the number 3. I'm saying add row 1 and row 3 to the number 2 up here. So do make sure that you get that clarified if you're not sure how I'm going from matrix to matrix right here. And also, the other thing, this is a very good example of something that you can check once you get your final answers. So just plug these three values in. They should make all three equations true if indeed they are correct. And finally, one thing I want to point out, one thing you cannot do when you're going from matrix to matrix is simply add a number to each. For example, let me look at row number 2 here. Well, it'd be nice if this was a 0, right? So maybe I think, okay, I want to add 3 to everything there. So I make this a 0, this a 4, this a 5, this a 2. You cannot do that. You can multiply and divide by any number, a row by any number, or you can interchange rows, or you can multiply any multiple of a row and add it to another row. All of those are fine, but you cannot simply add a constant number to each of the elements in the row. Okay, exact value. Certainly drawing a picture is nice because it helps you realize that this is in quadrant 4, and then we can just pick out cosine as the x-coordinate of this point on the unit circle, and sine as the y-coordinate. Okay, secant, key to remembering what secant is that it's secant of some value equals 1 over cosine, and really this is a kind of a memory device here, but if I want that to be correct, I really should have x or a theta in there or something. Secant itself is just a function that takes some kind of input. And if I just have secant, that doesn't really matter, doesn't mean much. So this is really just helping me remember what the relationship is between secant and cosine. And once I get the cosine, which is something I can find out just like number 6, question number 6 on this exam, then I just have to put that on the denominator and put 1 on the numerator. Okay, sum and difference. This was one of the more difficult questions on the exam. So when the problem is here, we don't know exactly what this value is. Now, several of you realized, okay, I need to split that into 2 angles, so let me think what I can do. Well, I know that pi over 4 is 3 pi over 12, 2 pi over 3 is 8 pi over 12. If I add those two, I'll get 11 pi over 12. And so you got the fact that 11 pi over 12 was equal to 3 pi over 12 plus 8 pi over 12. But then you just split it up simply without worrying about any formula. So you split this into cosine 3 pi over 12 plus cosine 8 pi over 12, and that is not correct. So we can split it inside of the cosine, but then to go beyond that, and here I guess I reduced the angles into their lowest terms that we're more familiar with, but to deal with this right here, we can't just distribute the cosine, because again, cosine itself isn't a quantity, it's a function. What we have to do here is use the angle, the sum identity, so that we're taking cosine of the first times cosine of the second minus sine of the first times sine of the second. And then we can, each of these 4 we can deal with individually using the unit circle so that we can reduce and get this final answer. Okay, period and amplitude. A lot of this is really understanding what the function is saying. So we know that this is a horizontal shift. The vertical shift would be added or subtracted to y, which there isn't one. Some people said that there isn't an amplitude because there's nothing out in front of the sign. Keep in mind that that's an invisible 1 there being multiplied by the sign. So when we were talking about the secant function, there really wasn't amplitude to talk about because it's going to infinity, but this one does have an amplitude, and it is 1. And then the period, to get the period, we just take 2 pi over whatever the coefficient of the x is, which is 6 in this case. Okay, this was the other very difficult question. So arc sine of negative 1/2 is going to give us, essentially we want the theta that when we take the sine we're going to get negative 1/2, which would be these, lost my pointer here, these angles right here. But so arc sine is an inverse function, and we couldn't make an inverse function of the entire sine function because it's not 1-to-1. And so what we do is we take just a tiny little chunk of that sine function and get the inverse of that. And so I've drawn that over here. This is the arc sine function. Notice that it can only take values in between -1 and 1, which isn't surprising, but it also has a range of -pi/2 to pi/2. So out of all these potential angles, that if we took the sine of any of these angles, we would get -1/2. We really can only take the ones in between -pi/2 and pi/2, and the only one out of all these angles that fits that is -pi/6. Okay, this one here, we take the square root of both sides and find out, remembering that we do have plus or minus, so when we work that out, we get plus or minus square root of 2/2. In other words, the x coordinate on the unit circle is either positive square root of 2/2, which would be these 2 points, or negative square root of 2/2, which would be these 2 points. So writing those all out, we would get these 4. And notice that we're limited to this interval 0 to 2 pi, which is why we don't have to worry about writing that plus 2 pi k, or we don't have to extend this out to get an infinite number of solutions. Okay, please let me know if you have any questions.